I'm kind of going through this pretty slowly because in past history, people find this far harder than it needs to be, because in grade 9 trig, people are pretty good at, if you said this is 1 and this is 2, find the missing side. They work through Pythagoras. They find that it's square root of 5 and whatever, right? And they're also good at finding the angles by using the inverse functions and all of that. For some reason, when we put it in this 12 context and we say, well, okay, it's not over there, it's rotated around to here, and you just have to use this little angle and this little triangle here to work with and find that angle. It's not really any different concepts, but for some reason people find it hard here. What is the sine ratio for that angle theta? This is theta. All the way around from there is theta. This thing over here is called theta reference, the little angle in there. What is the trig ratio for sine of theta in this case? You can either remember the definitions we put on the previous page. The trig ratios for this angle all the way over to here have to do with the coordinates and the radius here. What are the trig ratios? You can look at it in terms of this little reference triangle if that helps you remember it. The trig ratios for this are going to be the opposite from this angle divided by the hypotenuse. Right? You can think opposite over hypotenuse and you can say it's -1 over root 5. That's the sine ratio. You can say that the cosine ratio is what? What's a cosine ratio here? By definition, it's -2 over. Just remember that those ratios, when they're negative, they are for this angle theta, not for the reference angle. If I had asked you to write down sine of theta reference, what would the difference be? They would be positive, right? They would be, it would be, if that were over here, this would be +1, this would be +2, this would be root 5. That's the only difference there. The actual number is the same. The fraction is the same. It's just going to be positive. Okay, that's if you're talking about theta r. You could write this down as a decimal if you so choose to do so. Well, if we just put in the numbers here, -1 divided by square root of 5, -0.44, whatever. Well, we haven't looked at what it gives you when you put a negative in, but I'm going to write this down first. Roughly -0.447. And do the other one here. What would be the quick way of finding the other one without re-entering the whole thing? Well, it's 2 over that instead of 1 over that, so I'm just going to go times 2, right? Because it's twice as big. Or you could have gone second entry and gone back and changed the 1 to a 2, but that would be slower than just putting it in.
Why would the reference one be positive?
This isn't the reference. Why would these be positive? Because this angle is a small angle, and if it were, where does that reference angle start in here? Let's put a big, huge, thick pink line to show this. Where does this, when I'm measuring this angle right here, where is it starting? It's starting there and ending there. Is that the standard position for that angle? Standard position means start here and go that way until it ends. If we took that pink angle and moved it so it was in standard position, this is where it would be, right? So for the reference angle is always a positive angle, and it's always in quadrant 1, right? If you took that and moved it over there.
So it can be anywhere in quadrant 1.
When you talk about the reference angle, wherever, like you're looking at it in a different place on this picture, like over here, there's the reference angle, and up here, here's the reference angle. If you were to actually draw it so it was by itself on another set of axes in standard position, that's where it would be, and it's positive there.
Like it could be like 30 or it could be like 80.
Could be 30, could be 80, could be whatever. We don't know what it is yet. I just randomly drew it this size. You're right. I tried to draw it kind of to scale because of where that point was. That's a good question. What was this? Was this 8, 9 or something? -0.9. What was the next number, just for the sake of completeness here? 894. Okay. This is perhaps the big jump in thinking that you have to do here. If you want to find theta, the calculator isn't going to let you find theta directly. It doesn't tell you quadrant 3 angles. All we know at this point is when you put in a positive number, it gives you a quadrant 1 angle. You can experiment with that all you like with the calculator. You try any quadrant 1 angle on any one of the buttons. As in, you try sine of 48 degrees. That's whoops, we're in radians again now. Oh, no, that's the ratio. Yeah, sorry. I got to go backwards. If I do sine inverse of 0.8, I get quadrant 1. If I do sine inverse of 0.2, I get quadrant 1. That's degrees, right? 53 degrees, 11 degrees. If I do sine inverse of 1 degree, I get pretty close to 90. It's obviously rounding it off. Anything you put in for this, 0.94, what? Oh, 94, not 0.94, 0.94, I missed the decimal. 70 degrees, and so on, right? Whatever ratio you put in there that's positive, it gives you a quadrant 1 angle. So if I could find this, one way to do this would be to find the reference angle first, using the positive ratio, and then just knowing that that's the reference angle using the picture to find the actual angle. Okay? So this is what's happening here, what we're going to do. Find and you should maybe write it somewhere. Find theta r using the positive ratio. This is our strategy here, okay? Then use theta r to find theta. That's the strategy. You did this all the time in grade 11, but you probably didn't realize what you were doing. Okay, then use theta r to find theta. You did. But you're learning it again because you can gain some understanding from this. I don't, because one of the biggest things is people don't understand, why am I not going to use the negative ratio when I'm finding the angle in this quadrant? Because we know the ratio is negative for the angle in this quadrant. Why can't I use the negative ratio? I am first going to find the reference angle. Sine of theta reference is, what did we say it was? 1 over root 5. If I want to find the reference angle, what I do is I say sine inverse of 1 over root 5. That's going to give me the reference angle. It's really important to understand that you're finding the reference angle first and then you're going to use that. So go to your calculator and do what we were just doing here. Sine inverse of 1 divided by root 5. You can put it in brackets so that you use the exact value, or you could find the decimal number first and then do that. That's one way to do that. Oops. Okay, one way to do it is to do that. The other way to do it would be to do this separately first. 1 divided by root 5. And then do sine inverse of that answer. Right? You could do that. That gives you the same thing. That is the reference angle. It is approximately equal to 26.5 degrees. Notice on the picture, go back to the picture now. The picture is becoming a mess, but that's this angle right here. This pink angle. If that's 26.5 degrees, what is theta all the way around from there? Yeah, 180 plus that, right? Theta equals theta reference plus 180, or you could probably make more sense to say 180 plus because you're starting there. You're starting with the 180 and you're adding on the reference angle. 26.5, actually, what's wrong with this symbol here? It should say roughly equal to 206.5 degrees. Okay, do you understand the logic there? We're not using the negative ratio even though we know that this has a negative ratio, because on the calculator, the negative ratio doesn't give you a quadrant 3 angle. You can go back to your calculator to do it, and I'm at 10 minutes here, right? We can get this in here? We can fit this in. If you do sine inverse of the negative ratio. Oh, come on. There it is. Oh, no, I got to go insert here. Can I make it? It doesn't give you the angle in quadrant 3, it just gives you a negative angle. That's why we don't find it directly, we find it indirectly. To be continued.